Welcome to Unacademy. I welcome you all for the Unacademy YouTube channel. This is your Sathyamoorthy sir. Let's crack it. And today we are going to discuss about the integral calculus part 2. So we have started the basics of the integral calculus, some properties and types of the integration in the previous video. In this video, completely previous year questions relating to the integral calculus. The previous year questions will be discussed from this session. And before moving to the session, day after tomorrow, coming 27th, we are going to have the Unacademy Compact. So use the referral code Moorthy536 to unlock your free plan to attend the Unacademy Compact test. Already June 6th, 13th and 20th test over. Now the next test, day after tomorrow, starts at 11 AM. Take it live to compete with the best, super fast, fun with the all India live leaderboard. Identify and improve your weak areas through the detailed video solutions. After completing the session, and you will get the detailed video solution for each question in the compact test. Unacademy Compact, compete, crack and conquer. And if you secure the rank from 1 to 3, Unacademy complimentary subscription, 1 year subscription will be provided for the students. And if you secure 4 to 11, the rank from 4th to 10th, then you will get the 75% offer. And rank 11 to 50, you can get 50% offer on the Unacademy Plus subscription, venture of your choice. And 51 to 100, 25% offer. And the price hike is coming soon in the platform. July 1 onwards, the price hike will be there. So take the subscription now itself to avoid the price hike. And SPAR for GATE 2022 and SPAR for GATE 2023, English batches only, mechanical engineering, complete English batch course. Praveen Kulkarni sir, Devendra Singh Negi sir, Vivekanandan sir, and myself. We four together handling complete course for mechanical engineering. It's completely in English. In this batch course, engineering mathematics and general aptitude are also discussed along with the course subjects. Fine. Use the referral code Moorthy536 to join into the batch. Already course started on 16th June, and if you start the preparation, so you can complete the complete syllabus within 6 to 8 months. And one more batch C will be started, and 30th June, batch C, 30th June, batch C will be started, right? Here Akash Tyagi sir starting the course. Rajiv Singh going to start the course, right? So try to subscribe the batch courses using the referral code Moorthy536. So these are the all India ranks secured by the Unacademy learners. It's a mechanical engineering all India ranks, production engineering all India ranks, engineering science all India rank, civil engineering all India rank. So these are the chemical engineering all India ranks, and computer science and IT. So these are the top 100. So below 100 rank, below 100. So these are the Unacademy learners. They have secured the all India ranks in the 2021. And electrical engineering all India rank, electronics and communication engineering all India rank, and instrumentation all India rank, environmental science and engineering. So these are all the Unacademy students air rank, right? So you also can get same kind of all India rank in the 2022 as well as in the 2023. And the only thing you need to take the subscription now in the Plus platform to get the complete syllabus, weekly test, and electronic study material available, and complete doubt clearing sessions, and weekly quizzes, mega quizzes, full length mock test series for the subjects. Everything will be conducted in the Unacademy platform. So try to take the Plus subscription. Today we are moving to the integral. It's part 2. Today we are going to discuss part 2, integration part 2, integral calculus. Yesterday we have started the basics. I think it's not available in the yesterday's video, right? Integral calculus two types. One is definite integral, indefinite integral. Indefinite integral means there is no limit. Without limit, first we are completing the integration. Whenever, so f of x into dx, while integrating with respect to x, capital F of x. So it's an indefinite integral. It belongs to the indefinite integral. And if you want to convert this indefinite integral to the definite integral, then we need to apply the limits. And if we apply the limits, indefinite integral will be converted into the definite. So this is what we are doing, right? Integral a to b, limits. It's a green color. By applying the limits, we are converting the indefinite into the definite integrals. Is it clear? Okay. It's equal to f of b minus it's f of a. So this is the condition, right? So here by applying the limits, we are converting the definite into the indefinite, and properties of the integrals. And if we change the limit, then the sign of the integral value will be changed. It's minus. A to b, here b to a, it's minus. And the intermediate, we are splitting the integration by applying the intermediate points. Integral of a to b, f of x into dx is equal to integral of a to c, f of x into dx, plus integral of c to b, f of x into dx. Is it clear now? Now it's the one more very important property. Integral of 0 to a, f of x into dx is equal to integral of 0 to a, f of a minus x, the limit minus x into dx. Then one more very important property, minus to plus. Whenever the integral from minus to plus, f of x into dx, and for this set of integration, when the function f of x is odd, integral value is 0. If it is even, this function is applied only for the even function. Okay, it's applicable only for f of x even. Right, when it is odd, the value is equal to 0. By applying the limits, integral of 0 to a, f of x into dx, plus 0 to a, f of minus x into dx. The same equation we can write, it's 2 into integral of 0 to a, f of x into dx. So this is the condition. And then fifth integral property. So coming to the fifth property, integral of a to b, k into f of x into dx. Here k is the constant. So while doing the integration process, we need to keep the k outside. And sixth property, integral of a to b, f of x plus g of x into dx, it's equal to integral of a to b, f of x into dx, plus integral of a to b, g of x into dx. We are splitting the integral functions, right? Now by using these properties, we are going to start the previous question. So three methods yesterday we have discussed. One is substitution method. Three methods in the integration part. One is logarithmic function. Integral of f dash of x divided by f of x into dx is equal to logarithmic of f of x. It's a first one. Second one, substitution rule. Substitution method, second method, right? Third method, integration by parts. Third method, integration by parts. Whenever the given two functions depends upon the variable x or y variable, the given variable, and it belongs to the integration by parts. For the integration by parts, integral of u dv, it's equal to uv minus integral of vd. It's a formula for the integration by parts, right? It's integration by parts formula. Now we are going to discuss the third type, integration by parts. It's very important one, the repeatedly coming type, integration by parts. Few previous questions I am going to give you now with the previous questions, so you can get some clarification on the integration by parts. First one, it's a mechanical engineering 2013 question. Okay, it's mechanical engineering 2013 and 2 mark question. Here it's integration by parts. Integration by parts. Yesterday so we have discussed the function u. We have assumed it as u is equal to x, but here we can't take u is equal to x because we can't differentiate the logarithmic of x. So we can do the integration, but we can't differentiate the logarithmic of x continuously, right? Logarithmic of x differentiation, it's a little bit typical one. Now I'm going to give you the integration by parts method. Integration by parts. So now I'm going to compare this equation. Now, so this is the formula. Integral of u dv is equal to uv minus integral of v into du. So this is the methodology. So we require the value of u, v, du, everything. Now the given equation is compared. Now I am comparing the given equation. First one, without applying the limits. First, indefinite integral. Without applying the limits while calculating the integration, it is called as indefinite integral. First we are going to identify the solution for the indefinite integral. Then finally, after completing the integration, we are going to apply the limits. That means we are going to convert the definite value. And it's root x into logarithmic of x into dx. It will be compared with integral of u dv. Now, the which parameter is u, which parameter is x. So this is what we need to decide now. Now, usually if x into e power x or root x into e power x means we can't take the e power x as u, because while doing the continuous differentiation it must be 0. These concepts already we have discussed in the previous video, right? Engineering mathematics, integral calculus part 1. In the part 1, from its basics already we have discussed, right? In case you are having any doubt on that in this step, so you can watch the previous video, so you will get a clarification. Now here I am going to give you here u. What is u? Logarithmic of x is u. Whenever the logarithmic function comes into the integration by parts method, so we need to take u is equal to logarithmic of x. The remaining part dv is equal to root of x into dx. Root of x into dx. Now du, what about the du? Logarithmic of x differentiation 1 divided by x into dx. It's a du. Now we require, what are the values we require? U already in the question, and v we require. While integrating the dv with respect to v, then we will get v. So integral of dv is equal to v, x power 1 divided by 2 integration, x power 3 divided by 2 divided by 3 divided by 2. It's a condition. So this is the integration, right? Now we are going to apply into the uv formula. We are going to apply these values into the uv formula. Now integral of root of x logarithmic of x into dx. It's equal to uv. U is equal to logarithmic of x into du is equal to 1 divided by x into dx. V we require, right? So v is little bit different, but wait a minute. What about the v value? uv. V is equal to x power 3 divided by 2 divided by 3, 2 divided by 3. Into x power 3 divided by 2 divided by 3 divided by 2 divided by 3 divided by 2 minus integral of v du. V is equal to x power 3 divided by 2 divided by 3 divided by 2 into du. Du is equal to 1 divided by x into dx. Now do the simplification. Now it's 2 divided by 3 x power 3 divided by 2 logarithmic of x minus 2 divided by 3. Now x and x power 3 divided by 2 cancel. While cancelling this value, what we are getting? It's x power 1 divided by 2 into dx. Now do the integration. It's 2 divided by 3 x power 3 divided by 2 logarithmic of x minus 2 divided by 3 into x power 3 divided by 2 divided by 3 divided by 2. It's an integration. Here we should not apply the limits here, because here the function itself, it's a formula. The formula itself we are having the integration. So for the given function, integral of u into dv is equal to uv minus integral of v du. uv minus integral of v du. So here solution for this indefinite integral. So this is the value. After identifying this value, then we need to convert this equation by applying the limits. By applying the limits, we are converting into the definite integral. Okay, I'm giving it lesser. And here, now we are going to apply the limits. While applying the limits, it's equal to 2 divided by 3 x power 3 divided by 2 logarithmic of x minus 4 divided by 9 x power 3 divided by 2. Now the limits, by applying the limits, we are converting the indefinite integral to the definite integral. Now what will be the limit? 1 to e, 1 to exponential is the limit, so it's 1 to e. Now apply the limit. First, the red color, it's solution for the given integration without limit. After identifying the solution, we are applying the limits. For example, if you integrate the x, so x square divided by 2. After integrating the x value, then only we will apply the limit. So the same kind of process we are using here, right? Now substitute upper limit. If you substitute the upper limit, 2 divided by 3 e power 3 divided by 2 logarithmic of e minus 4 divided by 9 e power 3 divided by 2 minus its upper limit minus lower limit. If you substitute 1 and 2 divided by 3 1 power 3 divided by 2 1 power 3 divided by 2 logarithmic of 1. Here the logarithmic of 1 is equal to 0 minus 4 divided by 9 into exponential power. Exponential, we need to use exponential power 3 divided by 2, right? Fine, it's 1 only. Instead of x, we are replacing. Logarithmic of 1 is equal to 0. Okay. 1 power 3 divided by 2, it's logarithmic of 1 minus 4 divided by 9 into 1 power 3 divided by 2 while applying it. And what will be the value we are getting? So coming to this part, now finally logarithmic into exponential, that means logarithmic of exponential is equal to 1. Value is equal to 1. Now the solution is equal to 2 divided by 3 e power 3 divided by 2 e power, it's a 3 divided by 2 exponential power 3 divided by 2 minus 4 divided by 9 exponential power 3 divided by 2, then minus its logarithmic of 1 is equal to 0, minus of minus plus 4 divided by 9. Now do the simplification. So we need to take the LCM, right? If you take the LCM, multiply the 3 on both numerator and denominator. Now 9. If you take the 9 and 3, 6 into e power 3 divided by 2 minus 4 into e power 3 divided by 2 plus 4 divided by 9, it's equal to 2 divided by 9 into exponential power 3 divided by 2 plus 4 divided by 9. So we can write it's e power, so we can write the e power 1 divided by 2, it's 2 divided by 9 root of e cube, 1 divided by 2 is equal to root plus 4 divided by 9. So this will be the final answer, right? And 2 divided by 9 into root of e cube into plus 4 divided by 9. Here it's option C. Option C is the right answer for this question. I hope it's clear for everyone, right? It's a first problem. Yes, Darabur Reddy Sai Kumar, daily we will have class at 5:30 p.m. in YouTube. Yes, Reddy. And tomorrow and coming Monday, 2 more sessions available in the integral part, right? After completing it, and July month onwards, we are going to start the new topics. Okay. The one more problem now I am going to give you for the same method. We are discussing the third method, that integration by parts. We are discussing the third method, integration by parts. It's a first example. It's easy one, right? The one more easy method I am going to give you now. The value of following definite integral round off to the 3 decimal places. Again, x into logarithmic of x. So we need to compare this equation with integral of u dv. What is the formula for the u dv? uv minus integral of v du. Right? We require the u value from the given question. U is equal to logarithmic of x, and dv is equal to x into dx. We require the u, v as well as du. U already available. V we need to calculate, and while integrating the dv we will get v. Du and differentiate on both sides u. Du differentiation equal to 1 logarithmic of x differentiation 1 divided by x into dx, and integral of dv is equal to v. It's equal to x square divided by 2. Now substitute these values into the equation. Now we need to substitute these values into the equation. Now the integral of, first identify the indefinite integral. Then by applying the limits we are converting this equation into the definite integral. X into logarithmic of x into dx. Is it clear now? X into logarithmic of x into dx. It's equal to uv. U is equal to logarithmic of x into v is equal to x square divided by 2 minus integral of x square divided by 2 into dv is equal to 1 divided by x into dx. This value is equal to x square divided by 2 into logarithmic of x minus, now take the x square and x cancel, it's x, 1 divided by 2 into integral of x into dx. While doing the integration, it's x square divided by 2 into logarithmic of x minus x square divided by 4. 1 divided by 2 into x square divided by 2. Now we are going to apply the limit. So now we need to apply the limit here to convert the equation into the definite. It's an indefinite solution. By applying the limits we are converting to the definite integral. Now substitute the limit 1 to e. Lower limit 1, upper limit e. For the same equation we are substituting 1 to e. While substituting the upper limit minus lower limit, e power 2 divided by 2 logarithmic of e minus e square divided by 4. Its upper limit minus lower limit minus 1 divided by 2 logarithmic of 1 minus 1 divided by 4. Minus 1 divided by 4. Right? Now logarithmic of 1 value is equal to 0. Now it's a logarithmic of e, it's equal to 1, e square divided by 2 minus e square divided by 4 plus 1 divided by 4. While doing the simplification, what we are getting here, it's e square divided by 4 plus 1 divided by 4. And what will be the value of e square 1 divided by 4? So we need to do the simplification, right? Use the guys, kindly practice the problems with GATE virtual calculator, right? And if you use the normal calculators in the practice sessions, so while moving to the GATE examination, it's a little bit hard to use the virtual calculator. So in the practice itself, try to use the virtual calculator, GATE virtual calculator. It's available in the internet itself, or you can download from the Play Store in your mobile phone. Now the e square, exponential square divided by 4 plus 0.25. It's 2.097 is the solution here. It's equal to solution 2.097, and round off to the 3 decimal places. 3 after the decimal point, 3 digits. The solution for this question is equal to 2.097 is the solution. I hope it's clear, right? The one more example. Today we will complete the type 3. In the forthcoming videos we are going to discuss the remaining things. Now integration of logarithmic of x into dx. What about the value of logarithmic of x into dx? So this is what we need to discussed, right? Now logarithmic of x, whenever they are giving the logarithmic function, the x value is equal to logarithmic function. Again, now equate this value, integral of logarithmic of x into dx is equal to u dv. What about the value of u as well as v? So this is what we need to identify. Now u is equal to logarithmic of x, dv is equal to remaining part, and other than the u value, remaining things are dv. dv is equal to dx. dv is equal to dx. So this is the value, right? Okay, I'm giving it, listen. Now du is equal to logarithmic of x, it's 1 divided by x into dx. The integral of dv it's equal to v, dx integration equal to its x. Now substitute into the uv formula. By substituting into the uv formula, integral of logarithmic of x into dx uv, we know that it's equal to uv minus integral of v du. uv is equal to u logarithmic of x into x, right? B minus integral of x into dv is equal to, what about the du? dx into dx, it's equal to x into logarithmic of x minus x cancel, integral of dx, it's equal to x into logarithmic of x minus x, it's equal to x into, now take the x commonly outside, it's a common take, and if you take the x commonly outside, it's logarithmic of x minus 1, x into logarithmic of x minus 1. So coming to the options, it's option C. Is it clear now? Here option C is the right answer for this question. Okay, the one more example I am going to give you, then you will get it, right? A similar kind of part. So here dx mixing, right? And what will be the solution? X into logarithmic of x into dx. In this question, we need to compare with this question with the integration by parts formula. And if you compare this first indefinite integral, first we need to do the indefinite integral, then we are applying the limits. By applying the limits, we are converting the indefinite into the definite integral. X into logarithmic of x into dx, ln x or logarithmic of x, right? Now do the problem, integral of u dv formula. We need to take the value of u, v and everything here, right? U is equal to, the value of u is equal to, whenever they are giving the logarithmic function in the integral integration by parts, the u must be logarithmic of x while doing the continuous differentiation. Okay, so while doing the, we can't do the integration there, right? Logarithmic of x, we can't do the integration, so that's why we are assuming y u is equal to logarithmic of x, the remaining parts dv is equal to remaining parts x into dx. Now the uv formula we require here, it's equal to uv minus integral of v du. We require the value of du as well as v. Now u they are giving, du is equal to, differentiate it on both sides, logarithmic of x differentiation 1 divided by x into dx. Now dv, the differentiation of, integration of dv is equal to v, its integration of x into dx is equal to x square divided by 2. Now apply these values into the given question. Okay, listen, now I am doing it. Integration of x into logarithmic of x into dx uv, logarithmic of x into v is equal to x square divided by 2 minus integral of x square divided by 2 into 1 divided by x into dx. So how can we find the rational numbers between root 3 and root 2? In this question, we are not using any rational numbers here, right? here we are not using any rational numbers. I will explain it. Wait a minute. Okay, after completing this question. Look at this condition. Now it's logarithmic of x. Logarithmic of x into x squared divided by 2. Now the x and x square cancel. It's minus 1 divided by 2. X integration equal to integration of x into dx. It's equal to x squared divided by 2 logarithmic of x minus it's x squared divided by 4. X integration equal to x squared divided by 4. Is it clear now? Now by applying the limits, we are converting the indefinite integral into the definite integral. So what are the limits given in the question? So we need to apply these limits. Now, so this is the limit 0 to 1. After identifying the integral value, we need to apply the limits. By applying the limits, indefinite integral is converted to the definite. So if you want to get the clarification of the definite as well as indefinite, in this previous video, integral calculus part 1, so we have discussed the types of integrals. So there you can find, right? Watch the previous video also to get the clarification. Now apply. While applying the limit, upper limit 1 divided by 2 into logarithmic of 1 minus 1 divided by 4, right? Minus it's completely 0. 0 minus 0, lower limit. And logarithmic of 1 is equal to 0. Remaining value, it's minus 1 divided by 4. And solution for this question is minus 1 divided by 4 is the solution. It's option C. Option C is the right answer. If I am giving one more question, so you can get the complete clarification. Already 3 problems we have discussed in the world of integration by parts, right? So these 2 more questions available, so you can practice with these questions. So these are the questions. Double time integration by parts we will get here. So how to do this problem? Here sign, its modulus indicates that both positive and negative loop. We are having the both positive and negative loops in the sign, right? Here it's a positive, x into sin x minus x into sin x. Now the loop is split into 0 to pi and pi to 2 pi. So how we are doing the integration for the 0 to 2 pi into modulus of x into sin x into dx it's equal to. So in this question, how we are doing this process? Listen. Now integral of 0 to pi x into sin x. X into sin x into dx minus integral of pi to 2 pi into x into sin x into dx. First x into sin x, first we need to identify the one function first, right? First try to identify the indefinite integral value for the x into sin x, then we can apply the limits. And if you do the x into sin x, integral of x into sin x into dx. UV formula here, u is equal to x and dv is equal to sin x into dx and du is equal to dx and v is equal to integral of dv, sin differentiation equal to it's a cos, right? Now substitute into the uv formula, and if you substitute into the uv formula, integral of x into sin x into dx. So how to get the value? So this is what I am doing. It's equal to uv x into cos x minus integral of v into v cos x into dx. Cos x into dx. So this is what we are going to do, right? Is it okay now? Integral of sin x is equal to minus cos x. Fine. It's integral of sin x minus cos x. Here also we are getting it's minus cos x. Is it clear now? Okay, fine. Now x into cos x. Yeah, it's integration of sin is equal to minus cos. Now x into cos x uv minus integral of v into dx. V is equal to minus of minus plus cos integration equal to sin x. So this is what we are getting, right? While applying the upper and lower limit, sin obviously gets eliminated, right? Because sin 0 0, sin pi 0, sin 2 pi also 0. So while applying the any limits in the given part, it will be 0. So we are eliminating. The only thing, directly we are applying the limits here. Now by applying the limits, we are going to convert the equations. And what limits we are going to apply? Integral of x into sin x into dx. First one, 0 to pi, we are going to apply here x into cos x, right? While applying the 0 to pi, it's equal to pi into cos pi minus 0. It's equal to cos pi is equal to minus 1. It's a minus pi. Second one, integral of pi to 2 pi x into sin x into dx. It's equal to x into cos x. Now substitute, its upper limit 2 pi, lower limit pi. Now 2 pi into cos 2 pi minus pi into cos pi. It's equal to, cos 2 pi is equal to 1. 2 into 1 minus pi into minus 1. It's equal to 3 pi. Now the integral value. So already we have discussed about the integration for the condition. Integral of 0 to 2 pi modulus of x into sin x into dx is equal to integral of 0 to pi x into sin x minus integral of pi to 2 pi x into sin x into dx. Both we need to multiply the dx in both. And if you substitute, what value we are getting? It's a simple one, right? So we need to take the value with the plus or minus conditions. So this is what we are going to identify the value here, right? Wait a minute. Now it's minus we need to do. Is it okay now? Yes. Here it's modulus value, right? And if you take the value pi minus 3 pi, is it right? Yeah, fine. So this is what we are getting. Excuse me. Wait a minute. Oh, here minus cos. Oh, fine. Here also one minus missing, right? It's minus cos x. So while substituting the value, here also it's a minus. Yeah, while integrating it, one minus missing, right? So here it's minus. While substituting minus of minus, it's a plus. And if you substitute the minus here, it's minus 2 pi. Already here plus, minus, here plus, and we are getting the value is equal to minus 3 pi. Now the value pi minus 3 pi, the value is equal to pi minus 3 pi. Its total is equal to 4 pi, right? So we need to compare. 4 pi they are giving, but the given value is we need to identify the value of k. It's equal to 4 pi. Therefore k is equal to 4. The value of k is equal to 4. Sir, how are time and distance absolute terms? Where you are asking in the general aptitude part, speed is equal to distance divided by time, right? So if you want to identify the constant speed, then these terms are absolute terms, right? And the special class, in the Unacademy special class, so I have completed the time, distance, speed related problems. So you can get the clarification on the absolute distance and time in the special classes, aptitude class number 3. Okay. Thank you guys.